Yeah, so we often have more than one question we want to know. More than just a left or right branch. We'll have a whole bunch of paths we could take. So to abbreviate this, and we have it in most languages, if we've got an if inside of our else block, we can just bring all of that up here and put it beside the else. So instead of putting it inside of there, we can just bring it up and tack it on right at the end of the else. So then we have an else if, and we'll put our next condition. Some Boolean algebra. And then we'll do the stuff for condition 2. So then we're going to have multiple things that could be true. So do first stuff, then do second stuff. And then we can continue that down for quite a ways. And eventually we often want to include a default case. If none of those conditions we just checked are true, then we'll have a default way down at the bottom, a default else. Because if none of the conditions we're checking are true, we still want to do something in most cases. So, and we call this, instead of an if else, that's what we were looking at a minute ago, and nesting if else's, we can abbreviate it to an if else structure. And so, okay, so yeah, so just an abbreviated syntax that's available in most languages to make it a little clean, the code look a little cleaner than nesting those if blocks inside of the else block. Because that's like if you're doing it with indenting, it's going to keep getting further and further and further over, and starts to get a little messy if there's a lot of them. At least this way, they're all kind of at the same level when we write out our syntax. So now we're ready to get into examples. And again, the examples are just to demonstrate the generalizations. We have to talk about generalizations because every problem is a new problem. So make sure you're learning the generic form. That's something that sometimes catches software developers. They get used to copying examples, looking it up online. You can go to Google and ask how to do it, and then they'll just copy that example, and then they're only learning how to copy that example. They can't get back to the generic form, and it's like a trap. So we're in a dynamic field. IT is a very dynamic field, so obviously it's changing on us. We want to stay up to date, and we're going to look stuff up, see if improvements have been made since the last time we did something similar, that sort of thing. But be careful looking up exact examples. Make sure you give it a try first. My rule of thumb is I'll try 3 times. If I can't figure it out in 3 tries, I'm going to look it up, because unless I have a lot of time, because sometimes I just want to sit there and figure it out, but that might take a while. A lot of trial and error. So I usually try at least 3 times just to figure it out. And then if I can't, then I'll go look it up. But you don't want to get stuck in that cycle where all you learn is how to copy an example. Well, for lesson plans, obviously, we're doing stuff that's already been done. But in the real world, if it's already been done, is there really a point in doing it? So make sure you're learning the generic process for doing this, and not just copying every example and only learning how to look up the example you need to copy from. So the generic form, because every problem is different. So let's work through some examples now. Okay, so our first example here that I was thinking is an example of an if-else structure, a yes or no. A simple branch that goes one way or the other. And I put it up here earlier, our International Standard of Communication, the symbol for branching selection structures will be a diamond shape. So we'll put our condition in here, and then the answer to that will either be yes or no, and we'll fill out the steps of what to do if that condition is met, or what the steps to do if the condition is not met. So what I had in mind for this first one is a payroll calculator. Most of us, I think, are familiar with how payroll works, right? Not getting super advanced here, just, uh, well, trying to do different steps for making plans, and the last time it was a highly organized plan, so let's make a mess of the plan this time. So what does a payroll calculator need to do? So we need to get hours, and really accentuating the make a mess part, because maybe that works best for your mind. I'm trying different things. So we need to get the hours worked. That's something we need to do. I'll draw a little bubble around it. This to kind of like what I do. I tend to jot notes down on Post-its, and I have a stack of Post-it notes and move them around and reorganize it, and that seems to work well for me. So try to simulate that on the board here. So one of the Post-it notes is we got to get the hours worked. Well, then this part we got to check bigger than 40. Right? Because if it's bigger than 40, well, that's where we branch off. And then it's either regular pay or overtime pay. And, kind of making a mess of the design phase here, just to try different methods. And you're going to want to experiment around, see what works best for you. So that's basically what we need to do. Get the number of hours worked. If it's bigger than 40, if it's not bigger than 40, they just get the regular pay. If it's bigger than 40, then they get the regular pay for the first 40 hours and then overtime for the rest of it. That's kind of the idea. We'll probably make it look a little bit cleaner by getting a name and stuff, right? Get name. That way we can put a nice looking output, like user inputs Sally worked 25 hours. So then when we get to the output, we'll say Sally worked whatever it is, gets paid however much. Oh, I guess I need to get payroll. Get pay rate. That's kind of our main steps. So now that we have the parts down, what order do they need to go in? We'll probably want to get the name first. That way, when we prompt for the payroll, like the example I just said, Sally. So we get the name, they enter Sally, and then on the next prompt we can say, how much does Sally make? And then use that name in the subsequent prompts. So maybe that would be the second one. I guess we could do either that one or that one next. Get the information from the user. What's the name? How much do they make? How many hours did they work? And then we'll make a decision on how much they should get paid. So that's the rough design idea for the plan, and I tried to kind of simulate what I found works best for me, which is a mess of Post-it notes. So then I can move them back and forth and rearrange things and structure it together that way and just have all the steps wrote out on different Post-it notes. So let's translate this into pseudocode real quick and then do the example. Okay, so I'm just going to do the pseudocode in a text editor here. That way we can refer to it when we're putting the Raptor program together. And maximize that. So we have all the thinking's done. So the formalizing it into what actually goes into the computer should be really quick now. Step one, we need to get the name from the user. So we'll write a prompt to the screen. So who's next? And be careful with this. Some of the other instructors may respond very, very poorly to informal prompts, and they'll be polite and stuff. I do that for a reason. As machines do more and more, and well, I'll put it in the form of an example. As machines are doing more and getting fancier, humans start to expect less formality from it, right? Like our smart speaker in our house. When we're doing stuff, it feels a lot more natural to interact with it if it's very informal. But at the same time, if we have a guest over at our house, we probably want the smart speaker to be polite to the guest the same way we expect our children to be polite to the guest. So that's why I do the informal thing, is thoughts like that. As machines do more, and the, I guess, reach towards the AI concepts, we expect a little informality from them. That's why I am informal with the prompts, but please make sure you know what your instructor wants, because some of the instructors will, it will be a big deal if you don't put a very polite prompt. But I do the informal one for a reason, user expectation sort of thing. So there's our prompt. Now that we have the name, well, the user will give that to us, and then we can put that set in place. So set name equal to the input. Then once we have that input, well, we need more information. How much do they get paid per hour, and how many hours did they work? So then we can write a couple more prompts. So write, how much does, and then work in that, that variable we just put. How much does whatever's stored in the name variable make? So how much money do they make? And then we'll set that to, I'll call it rate. Set rate equal to input. Whatever the user gives us, we'll store that in a variable called rate. And then, well, how many hours did they work? So another prompt, right? How many hours plus whatever stored in that name variable, just to help keep it straight, right? If there's 5 employees, then we can tell for certain if we're doing Sally's payroll or Bob's payroll or David's payroll or Becky's payroll, and it helps to keep it straight, being specific in the prompts. How many hours, oh, I forgot the word. How many hours did so-and-so work? And then that we'll put in a variable maybe called hours. Hours equals input. And now we're ready to do our selection and determine how much they're going to get paid. And we've already thought through what it needs to be. We just need to put it in a format the computer needs now. So our keyword for that, like we saw a moment ago, is going to be if, and then some condition. So if hours is bigger than 40, if they work more than 40 hours. And now to distinguish what is inside of that if block, I'm going to indent it. So if hours is bigger than 40, I'm going to hit tab and come over, and then everything that's indented is what will run if that condition is true. So if hours is bigger than 40, well then paycheck. The amount that actually shows up on their paycheck. That's a good variable name for it. Paycheck will equal this is our overtime, isn't it? So we need the first 40 hours to be regular pay. So 40 times rate gives the regular pay, but then we need to add the overtime pay to that. And the overtime, so plus, well, our overtime is whatever it was above 40. So hours minus 40. And I'm going to put that in parentheses to make sure that step gets done first in the math. So however many hours they work, subtract 40, and whatever's left is the overtime. So, and overtime is typically time and a half. So then we'll multiply that by their pay rate, and then multiply it again by 1.5 for time and a half. So the paycheck, if they worked over 40 hours, they get the money for the first 40 hours, just the regular rate of pay. And then whatever they worked in excess of 40 hours, we're going to multiply by that rate and then add times another 1.5 times. So that little bit extra for working lots of hours. So that's all we need to do if the condition is true. We worked more than 40 hours. So I'm going to undo the indenting because we just need to run that one line in this case. And else, so if that condition is not true, then we'll do this stuff. We're going to write the amount that goes in the paycheck will be the number of hours they worked times the rate of pay per hour. And then either way, whether the answer to that question is yes or no, we have our variable paycheck filled in with some sort of number of how much money they made. Oh, we only need to run that one line, and then our textbook uses the word end if to indicate in the pseudocode where we're finished with that, with the if block. So that finishes that. That's all the steps wrote up there, and it kind of omitted the obvious we need an output. So we'll throw that in the pseudocode here. Right. Let's see. Whatever's in that name variable. So Sally. So Sally plus made plus, well, we stored the number in the variable called paycheck. So maybe it's 120 in there. So Sally made 120 plus the words this week. That makes a nice thorough output. Explain what's, makes it very clear what those numbers mean. So whatever's stored in the variable, that variable, plus the word made, plus whatever's stored in that variable paycheck, plus this week, just to make sure the output is labeled clearly. So that'll put this program together. And notice how after all the thinking's done, the putting it into a computer runs very, very quickly. So let's put this together in Raptor now. And yeah, we'll put this together in Raptor, and then we'll do an example of the if, else, if, else structures. Hopefully all that kind of makes sense. We'll get our inputs like we were doing previously. And then when we do our calculation, there's two different calculations that could happen here. So we have to make a choice and figure out which one of those calculations we want to perform on this, on each particular pass through this software every time the program runs. And once we get that number, then we just output it. So the beginning and end there, like we've been doing, but we have this choice to make along the way. So let's go do that in Raptor real quick. Everything's thought through. It's already halfway between English, our natural language, and the computer code. That's what pseudocode is. So now we're ready to do the actual coding, which in our case is a flowchart interpreter. Okay, so I have Raptor open here, and I went ahead and saved the file so it won't interrupt in the middle of something, and ready to put this pseudocode together. So now that everything's ready, it should go fairly quickly. And you may remember from the last example, we split things up into subtabs to kind of organize it. So I'll do the same thing here again. So I'll have an input module to get all our numbers, then a calculate module, and an output module, just to help kind of organize everything, make it look a little neater when we code it up. So let's create these three subcharts here in Raptor. And remember, a subchart is it counts as being part of the same chart. We're just cleaning it up. It's kind of, we put some of it on another page to make everything look nice and organized. But any variables we create over in our input module, we can still access in our output module. So I'm going to set those three up. And I usually just go with this method of right click and add subchart. And I'm going to call this inputs. But we also have the option we can bring in a call statement and ask for a submodule. We're going to invoke a calculate subchart. So calculations, and it doesn't exist, so it will automatically create it for us. So either way works, or right click and add one more, add subchart for outputs. And that's just a way to help organize our code. So now we can start putting the pieces together. And another one we saw, whoops, did I put that in the wrong spot? That was supposed to go, I'm going to cut that. That was supposed to go on the main. So keep an eye on those. Make sure, because the main is the one that is really running. These are just sub pieces of the main pulled off and set to the side to make everything look a little more organized on the screen. So make sure it goes into the main. So that one's called. And remember we saw last time we can also invoke a clear console function that is already built to clean up all the junk from previous runs in our console. So we usually want to start out with that. That way we're only looking at the most recent output. We're not don't have to worry about the earlier ones. They get taken out of the way automatically. So we're going to clear the console. Well, on Pseudocode, we have the clear console, and then we want to run our input module, then run our calculate module, and then run our output module. So we'll do the inputs first. Well, I guess we can go ahead and call them here in the main. So we'll clear that, and then we'll run inputs, run the calculations, and then finally we'll do the outputs. So let's start with the inputs. And we have that in the pseudocode here. So we're going to write some sort of prompt, and then I discuss the point about why I like to do the informal prompts. Users have certain expectations as machines become more advanced. So I'll do a lot of informal prompts, but make sure you know what your teacher wants, because most of your instructors are probably going to be very strict about very polite, informal, proper prompts. So we want to get the name, then get the rate of pay, and then get the number of hours worked. So we'll bring in an input box, and the input has both features. What are we going to prompt the user, and where are we going to put what they give us? So for our input prompt, like on the pseudocode, put so who's next? And I always like to end in either a question mark or a colon. And as you noticed on these prompts today, they're kind of in the form of a question, but something to indicate to the user we're waiting on them to put something in. And whatever they give us, we're going to store that in a variable called name. And then that will create the variable name. And since this is just a subchart, we have access to that variable in all of the other subcharts or pieces of the main chart. So after we get the name, well, then we can use it in the prompt to make sure it's clear whose rate of pay is being entered. So I'll bring this over here, and it's going to look exactly like it's here in the pseudocode. So much so that I'm going to push Control-C to copy, and then Control-V to paste it. There's no need to type the same thing twice. That just increases the chances of making a typo. And then that's going to bring in this variable called rate. And we can do the same thing on this other one. I already typed what the prompt needs to look like, so I'm just going to hit Control-C to copy it. Come over here, bring in another input, and paste in that prompt that was already typed. And that'll store the variable hours. Well, whatever the user gives us, we'll put into this variable hours. So that sets up the data that we need for this. So that finishes the input section. And I'm going to jump a little out of order and go ahead and put together the outputs, because that's kind of like what we've seen already. And it's already typed, so that's just going to be copy. I'll do it with the mouse so you can see the buttons. So right click and copy, and then come over to this outputs module, bring in an output, and right click and paste. So there's no need to type the same thing twice. We already have it typed, we can just copy and paste. All right, now we're ready for the new part. The calculations in this example involve a selection structure. And I went out of order there to kind of help express the point. It has to finish in this order. This is the order the computer needs it in order to run, our sequential structure. But we do not have to create it in this order. We can jump back and forth, and often it's a better idea to jump back and forth and put it together in the order our mind thinks about it, as long as it finishes in the correct order, as long as it's in the right order at the end. So we're ready to do our calculations here. So we'll come over to that subchart, and in our pseudocode we wrote it like this: if, else, and then mark the end of it. But we have our if-else structure, so a branch. So we're coming down, and then we can choose to go to the left or to the right, depending on the outcome of this Boolean algebra statement. So our selection structure is, well, the one over here labeled structure selection. Let's bring that in, and there's our diamond shape to show that we're making a choice. And then we know the choice we want to make. We want to know if hours is larger than 40. So we'll just double click on the diamond, and we type that right in. Hours, and notice that the little preview thing did show up down in the little preview thing, so we can just start typing it and use the arrow keys and hit tab to let the computer do the typing for us. Because the computer will not make a typo. Or, perhaps we made a typo when we originally created that variable. And then every time we try to use it, if we spelled it correctly, that would, in essence, be a typo. So computers will never make typos, so let the computer type as much as possible. But our condition, we want to know if the hours worked is larger than 40. So we just need to put the condition in here. So it's like we're asking this question: is hours greater than 40? And the answer to that is either yes or no. It's either larger than 40, in which case we'll take this path through the flowchart, or it's less than 40, less than or equal to 40. And in that case, we'll take this path through the flowchart. So now we just need to put the stuff for each of those paths. And each one, it just has a calculation. We're going to calculate the value of paycheck. It's either the normal rate at 40 hours or time and a half rate for whatever exceeded 40 hours. Or on the no branch, we just set it the hours worked times the rate of pay. So let's do the no one first. That's an assignment for performing a calculation. So our volatile memory, or our volatile storage, which we usually refer to as memory, symbol for that. And we'll just go in here and we'll assign, we will assign whatever number hours times rate gives. That'll return some number, so then we're going to put that in this variable called paycheck. So paycheck is assigned hours times rate if we're less than or equal to 40 hours. But if we work more than 40 hours, we have a different calculation. So over on this side of the flowchart, we want to come in here and set paycheck to, well, this time, the first 40 hours, so 40 times rate. So just the regular amount for the first 40 hours, but we're also going to add a little bit to that. So I'm going to put two sets of parentheses. In the first one, I'll do hours minus 40. So that'll be however many hours they worked beyond 40. We'll get that number, and we do the parentheses first. So then we'll have that number to work with the rest of the way through. Remember, computers just follow the order of operations like we learned in math class for our arithmetic operations. and also our logical operations. Computers know the order of operations. So wrapping that in parentheses means we'll find that number first, and then we're going to multiply that by time and a half pay. So times rate times 1.5. And then close that other set of parentheses, and that'll be the overtime pay. The first 40 hours plus the extra. So that's how a selection structure comes together and it looks in Raptor. We'll check this condition, which is going to be a yes or no question. We ask a yes or no question, and we either take this branch or this branch. And while we're here pointing at stuff, this little symbol here will collapse it. So when those start to get big and maybe look a little messy, you have this symbol to kind of collapse it and get it out of the way. Make it look better on the page. So we already did our outputs, got our inputs. So let's give this a run and see if it works. And for this first run, I'm going to turn the speed down so that we can see it jumping back and forth between the tabs. So it'll leave and do some stuff, come back to the main. They'll go to this, hit this block. It'll leave the main, go over to this other subchart, do all that stuff, and then come back right to where it was. And then just continue on that way. So I'm going to turn it down for the first run so we can see it jumping around. So a name, let's put in Sally. And then that name shows up here in our prompt. How much does Sally make? To help keep it organized. So keep things like that in mind as you put the prompts together. Put them in an order that is most useful so we can, like, if we're going to work with a name, make sure you get the name first. That way the rest of the prompts can use that name to help make it very clear to the user what question is being asked. Let's say Sally makes $12.35 an hour. $12.34. And how many hours did Sally work? Maybe Sally worked 32 hours. Finishes it, comes back, and you can see it took that no branch in the condition, and Sally made $394.88. Formatting in Raptor is not pre-built. We'll look at that in a couple weeks, so for now let's just pretend like it's there. I guess we could throw a $sign in there. So let's go over to outputs and put a $sign. What is that thing? Okay. Sally made, and then a $sign to sit next to our number. We'll talk about formatting before long, how we can format this. The first couple times I taught the class, I showed a way to do it, but it's not the best way and it causes other problems. So we'll get to formatting these to look like money in a couple weeks. But now we can turn this up so the no branch worked, but we also need to check the yes branch. So I'm just going to run it and kind of let it go through really quick. So Bob, how much does Bob make? Bob makes, I don't know, $10.75 an hour. How many hours did Bob work? Well, we already checked the no branch, so we need to check something that would have overtime. So maybe Bob worked 43.5 hours. Runs through there, and Bob made $486.44, I guess, this week. And again, we will look at this before long. We will have how to format these numbers. But we'll be, for now, just go ahead and let them output and it'll be okay. We'll see that in week 6, I believe. And I'm going to do one more slow pass through here. Everything seemed to work. Might want to check some numbers that we can quickly calculate what it should be. I'm going to do one more slow pass so we can watch it change on that, which branch it takes here. So I'm going to turn the speed way down, run that. And we already know this works, so I'm just going to match the keyboard. I do need to make sure this is a number, so 5 and 5. Make sure those are numbers. But it's already been tested, but we can see here it went on the no branch. and did all the calculations and output that. So if we run it again, and this is an important whenever if something doesn't quite work right, make sure you turn that speed way down and watch what it's doing block by block, and keep an eye on the watch window and watch it at every step of the way to figure out where it's going wrong. We already tested that, so just mashing the keyboard, just any number here, but this one I want to make sure that's above 40 to hit that other condition, so maybe 65. That's a rough work beat, but then 65. So now when it runs through here, we can see it took the yes branch and then finished and did the rest of it. So if you hit problems, make sure you slow it down and check step by step, every single step, or use this button right here where instead of running, you're just running through each step of the thing. Let's walk through an example of that. So if we hit it once, it goes to the start shape. Hit that again, it goes to the shape, but it hasn't run it yet. Then we hit it again, it runs that, then goes to the next one. It hasn't run it yet though, so when we hit that, it goes over to the next one. Then we have to kind of hit that each individual time and go step by step until we figure out where a problem might have occurred at. But we can see here a choice was made. We asked that question and the computer was able to answer a yes or no question about these things. Okay, yeah, now I can just quickly go through to the end because I was into that point. So there's all that, and yeah, and then I always ask for a bug report with all of your stuff, which can be a very short write-up. So in this case, everything worked on the first try. Might as well add in here, almost like I had the ability to edit what was happening. I kind of made it nice there. But just a short write-up, just let me know how it went. If you hit problems, let me know about that so that I can address those problems and get it working for you. And again, this class, if this class was about programming, only the software development people and those who intend to transfer to a 4-year degree for computer science program would have to take it. So it's not about programming, it's about giving machines instructions. So the algorithm is the important part. The pseudocode is the main one I'll be looking at when I'm grading. And then the Raptor is so that you can see it run. So that finishes out that example. Let's look at an example with a more complicated selection structure. Because here we only look at one yes or no question. But we might have more than one question we want to ask. So let's look at an example of that real quick. Well, a slight change in plan from what I just said a moment ago. So instead of doing a second example, these videos there's been a lot of video lecture this week. So let's just put a couple more points in this one to express those. And then the second one I had in mind, which was going to be the card example, like we talked about with the set theory section, and lots of material this week. The rest of the semester, there's going to be less material each week, because now we've seen enough that you should be ready to start working on your final project. So I like to front load these classes so that halfway through or so, we're ready to work on the final project and less material so you can spend more time on the project with the stuff that you have seen. There's still a couple more basic things to cover here, so I'm just going to throw it in this example. And then the other one that I had in mind, and this might also work better, I'm going to do that as an optional video. So I'm still going to make the playing card example, sorting through those. And that'll be an optional video because I'll include all the parts here in just a second. And if that's an optional video, I will go ahead and instead of throwing words up to the console output to say what card it is, I'll go ahead and throw the graphics in there because, well, there's already playing card graphics we can download and use, and we probably want to see the picture of the playing card, not the words saying what it is. So I'll add that in as an optional video for this module. But all the content I want to include here is, I wanted to make sure and include that somewhere because I had that example in mind, because I know several people have already expressed an interest in video games, and card games is a good example and practice to get into making video games. So that will be an optional video. I will get that posted separate from this one. So let's go ahead and finish this one up real quick with other stuff we might need. So might as well show it here. What the other one's going to show is the if, else structures. The nested if structures, which when we're looking at a visual representation like a flowchart, the nested if structures make a lot of sense because we'll just grab an if structure and stick it inside of this other one. So, we have our yes or no. If it's yes, we do some stuff, and if it's no, we check something else. And then we have a yes and no there, and we can keep bringing those in and checking lots of things, and it could be, and kind of put them either place and make lots of branches for it. And also here with the flowchart interpreter, notice when I click this one, this top level selection structure, all of them inside of it highlighted, so I can delete all those ones. So the other part, if you run out of time and if you don't have time for the optional video, that's just nesting if structures. So bring another selection structure over and put it inside of the selection structure you already have, so that you can ask one question, and then if you don't like the answer to it, ask another question. It's sort of the idea. And the other thing that we haven't seen yet is those logical operators from Boolean algebra, like we talked about. We're checking a single Boolean algebra condition, but we might want to check more than one thing at once. I kind of alluded to it over here in the inputs, right? We ask for a name, and hopefully the user will give us a name. And then when we were running those second and third passes, just the quick ones, I made the point to state we have to be sure this is a number. And the question arises with that. Can we really trust the user to give us a number? Hopefully they'll give us a number, but if they give us something that's not a number, like we say, how much does so-and-so make? And they say purple, well, that's going to cause our program to crash. So this is getting into defensive programming, which we will talk about in detail before long, but can we really trust the user to give us a number just because we ask for one? So we want to be able to check for that. So that'll make a good example here of using one of our logical operators, and we'll just use one of them, and the other two will kind of follow suit with it. So here where we check if hours is bigger than 40, well, before we check to see if it's bigger than 40, we should probably check and make sure it's a number. So to do that, we'll use our logical operators. So I'm going to go in here and take out what's there. I could have scrolled over and edited before it, but if that was there, it prevents the little predictions from showing up. So I'm just going to take it out and I'll retype it in a moment. So we need to know if that's a number. And there is a pre-built function to check for us. So if I start typing is, well, here's some things we can check. Is this an array or a 2D array? Is it a character? Is it a string? Is it open-ended thing? But here's the one we want. Is it a number? And notice on the prediction here, is number, and then we'll put some sort of variable in parentheses that we want to know if it's a number or not. So with that highlighted, we can hit tab. So is number, and we want to make sure that hours is a number. So the first thing we want to check when we ask before we do our calculation is, do we actually have a number to work with? And well, we have two things in this calculation. We also have rate, so we might as well check that as well. Make sure the user gave us numbers when they were supposed to. So we can either type the word and, or we can use symbols. I like to use the symbols, so I'm going to use 2 ampersands, the symbol above the 7. So is the variable hours a number, and which means it has to be inclusive. Both things have to be true in order for this condition to take the yes branch. Well, we also want to make sure rate is a number. Well, I'll try to keep the example simple. We'd probably want to check the same thing with rate and make sure that rate is a number. That way it doesn't just crash. But to keep the example simple, I'm just going to make sure hours is a number before we go and make this comparison and then do our math. But we would do the exact same thing with is number rate and work that in. But there's a slight altercation where typing that here wouldn't quite be enough. And I think it's in Module 5 we're going to talk about defensive programming. So next week we'll talk about the details of working those protective conditions in and make sure, like, if we ask the user for a number, they give us a number. We can just get that. So that'll return true or false. If it's a number, it's going to say true or yes. And if it's not a number, it's going to say no. And is inclusive, so both of them have to be yes in order to take the yes branch. So if that is a number and that number is bigger than 40. So that's how our logical operators work in. We just type in the symbol, the 2 ampersands, or we could write the word and, hours bigger than 40. And, well, we also mentioned that, I'll type this in here, I'm going to come right back to this. We also mentioned that not is a unitary operation. So to do that, we would type not, and then in parentheses, hours greater than 40. Hours less than or equal to 40. So if hours is a number and hours is not less than or equal to 40. But as you can see, writing it that way is kind of messy. But that's how the not operator works. Just not, and then whatever you want to negate. Otherwise, the and or, we'll just type right in between the two things we want to check. So is hours a number, and is hours greater than 40? And if it is, well, then they get overtime. But if it's not, then we'll take this back. So and there's a slight, it's not quite defensive programming, but it's leaning towards that. We'll talk about that soon. So just a slight adjustment to our condition. Really here, whoops, not sure what I clicked there. Really, the point of this one is just to show how to use the and or, because that was still missing from the first example. And the second example, since there's already been so much this week, I'm going to make it optional. That'll be the playing card thing, the deck of cards example. And for a simple example, just kind of selecting a card, and then we'll throw the picture of the card up instead of words on there. But that'll be an optional video because these have gone on for a while, so all the content is here. This is how we put in our logical operators, either 2 ampersands or 2 pipe symbols for or you could write the words out, or we type the word not right before the thing we want to negate, and we can build up a long chain of Boolean algebra conditions, and the final result of it will be either true or false, yes or no.